Next, we're taking a look at a couple problems where they ask us to sketch the graph on these intervals. And they want us to determine whether the function has any absolute extreme values on the domain. So both of these ones, both 16 and 19, these are defined on open intervals. They're both continuous functions on those intervals, but they're open, so we're not guaranteed any. Maybe we have both, maybe we have one, maybe we have neither. That's what happens when we don't have both of those conditions fulfilled. But coming over here and taking a look at 6 over x squared plus 2 from the open interval from -1 to 1. And because that's an open interval, keep in mind we would graph the endpoints as open dots there. But what we do get here, we do get an absolute max of 3 at x equals 0. So even though our continuous function's defined on an open interval, we did end up with an absolute maximum. There is no absolute minimums here because, again, these are open endpoints. Next, we have 19, which is 3 sine x on the open interval from 0 to 2 pi. So again, that is open there, that is open there. So there's no guarantee of an absolute minimum or maximum, but we're in luck. We actually do have both here. We have an absolute maximum of 3 at x equals pi over 2. And we have an absolute minimum of -3 at x equals 3 pi over 2. So these last couple questions, again, are just going through the idea of when are we guaranteed a minimum or maximum, an absolute minimum or maximum. And then we can, even if we don't have the guarantee, we can still explore and we may still find them there.